So the toString method is a method that is declared on the object class. Now it's important to note that every class inherits from the object class. So even though in our class header we don't actually inherit from anything, every class automatically inherits from the object class. Now there's a few methods in the object class. You can go to the Java API to learn more about the object class, but one of the methods that we're going to override is a toString method. If I were to invoke toString on my student class, Java is going to look at my student class and see that I never declared a toString, and then it's going to reference the underlining object class's toString method. Now because every class is a child of the object class, the student class that we just created is also going to inherit any methods within the object class, including the toString method. I created this program so that we can test our student class. I instantiated an instance of our student object, and then I'm invoking the toString method, and I'm storing the result into a variable that holds a string. Now what I'm wanting to demonstrate is even though I did not create a toString method within my student class, this method is still valid because it exists on the underlining object's object class. Now every class inherits from the object class, so we also inherit all the methods from the object class. If I go back to my student class, you can see that there is no toString method that I've created yet. So let's see what happens when I compile this program. I compiled the program, I did not get an error. So I'm going to go ahead and print out the results. So I added this line so that I can see what this string is. So I'm going to go ahead and compile and run this program. And here are my results. This is actually pretty interesting. Now what this string is telling us is that the object that I invoked it on is of a student class. And this hex value is the address location of where it's at in memory. So this is the default for the toString method. Now the toString method actually automatically gets called whenever I concatenate my object to a string or whenever I pass my object to the println method. So I didn't actually have to create a variable to hold this result. I could have just simply made a system out println method and passed in my object. So here I made a println method and I'm passing in my object reference variable, and when I compile and run my program, I'm going to get the same results that I did when I outputted this result variable. So I'm going to go ahead and compile and run, and here are my results. So now what I want to do is I want to go back to my student blueprint class and I want to create a toString method. So I want to override the underlining object's toString method and make a method that makes more sense to me. So I'm going to go ahead and do that. So I created the method to override my underlining object's toString method. Now when we do this, we're going to declare the method to be public and we're going to return a string. We're going to name the method toString, and there's no parameters that get passed into our parameter list for this method. And then I'm going to have the return statement, and then I'm going to return some type of string here. Now the string that I'm going to return, I'm actually generating with the string.format method. So here is the string that I want to return, and it's basically just a snapshot of all my instance data. Now typically toString methods are used for debugging purposes only. So when I print out my object to the console, I just want a preview of what the current instance data is. And that's exactly what I'm doing. I'm getting the first name, last name, and then all my grades. So I'm going to hop back over to my student test driver class, and I'm going to go ahead and compile and run this program. Now I didn't change anything here, but this is the previous results. So let's see what the new results are. And here are my results. Now this makes sense because I instantiated my object right here, but I actually haven't set any of its data. So my first name is null, my last name is null, and the values for all my grades are 0. Now what null means, it just means that the object reference variable does not point anywhere. So first name and last name were declared to be strings. Now remember, strings are objects. So if I never set a string, that just means that that object reference variable that I declared to hold the first name and the last name is pointing to nowhere in memory because I haven't actually stored an object into memory. So let's look at the output of the toString method after I set some of the data. So I added these lines of code. I'm printing out a statement just to note that I'm setting data, and I'm setting my data for my first name, last name, quiz, assignment, midterm, and final exam grade. And then I'm going to print the object out. Now, when I print this object out, it's going to invoke the toString method automatically, and we're going to see our data change. This is the result of the toString method after I instantiated my object and not set any data. So I'm going to go ahead and compile and run this program, and here are my results. Now, one thing I haven't done in the student blueprint class is create a constructor. We can create a constructor that accepts data so that we can initialize some of our instance data. For instance, let's just say I don't want a student object to exist in memory unless a first and a last name have been passed into my constructor. If that's the case, I can create a constructor that accepts a first and a last name. I'm going to go ahead and create that constructor. Here's my constructor. I created a public constructor. So when I make my constructor public, that just means I can use this constructor outside of this class. And here's the parameter list for my constructor. I'm taking in a string for first name and a string for for last name. Now notice I intentionally made these variable names different than my instance data. If I use first name and last name, those names would match what I have for my instance data for this. Those names would match what I have for my instance data for this class, and Java would be confused on which one was which. So I'm setting the first name and the last name of my instance data equal to the data that is being passed in. Now once I create this constructor, that means that I can no longer create a student object by passing in no data into the constructor. So I go back to my student test class. When I compile, I'm going to get an error because this constructor has no parameters in it. So I'm going to go ahead and compile, and here's the error from Java. So Java is telling us that there's no constructor on the student class that takes no parameters. It's telling me I need to pass in a string and a string, and it found no constructors that take no arguments. So now what I need to do is pass in two strings into my constructor in order to compile this program. But also note, since I modified my constructor in my student class, I now broke my grade calculator 2 program for the same reason. So I'm going to come back over to my student test driver class. I'm going to pass in two strings. And now that I pass in two strings, Java should be happy, and I'm going to compile and run this program. And now the first time that I output the toString method, you can see that my first and my last name are being set. But in my grade calculator 2 program, if I were to compile this program, I would get an error. So that means I now have to pass in two strings into my constructor in order to compile this program. But what I'm going to do instead is I'm going to come over to my student class, and I'm going to do what I call overload my constructor. We'll talk more about this later. This means I can make a blueprint class that has more than one constructor so that I'm able to instantiate an object that takes in a first and a last name and an object that takes in no parameters. So I'm going to go ahead and create that constructor. And here's a constructor that takes in no parameters. I put default on it because it's doing absolutely nothing like what we had before. So now when I go over to my grade calculator 2 program and compile, it's happy. I know this is a lot of information to absorb at one time, but this is what we're doing for chapter 4. So you're going to have to practice this. There's plenty of videos online if you don't like my teaching style, but you need to understand this if you expect to pass my course. The midterm is going to be littered with questions about classes, so you need to make sure you have a solid grasp on these concepts.